Man, and I use the term loosely. Hey, before you hear, we got 4 magnetos and 2 rotor magnets, okay? This is a brand new Joe Hunt. This magneto has a new magnet in it, and it's got the adapter for putting it in a Sportster 1000cc Sportster tack drive. These are 2 stock Harley magnetos out of a 900cc Sportster. Over here, we've got 1 brand new
neodymium.
Over here, we got 1 brand new neodymium. Neodymium. I don't know. Neodymium.
Neodymium.
Neo something over here. We got a Neo. One of those new, supposedly never loses its charge. Neo something or another magnets. This is a Joe Hunt product. When you order these, you get the magnet and the shaft. I wanted a shaft with a spiral cut in it for the tack drive. They don't have one, so I had to settle for a straight drive, and that becomes important later on. But anyway, 2 magnets. These magnetos, well, this is a brand new Joe Hunt. I assume it works. This one has got a new magnet and an old coil in it. Maybe it'll work, maybe it won't. I don't know. These 2 seem like they should work, but they will not start a motorcycle. I could get a bike running, maybe once out of every 50 kicks. I've swapped coils around. I think this one's got a new coil in it. Yeah, this one's got a new coil in it. I don't think the coils are the problem. I think the magnets are weak. So we're going to do some experimenting here. We're going to test these, and we're going to measure some magnetic fields with a Gauss meter. And since this is the internet and YouTube, I can make up any stupid fucking shit I want, and there's nobody checking up on me, except, of course, you viewers will tell me if I'm stupid or not. But anyway, prior to making this video, I did do some research. And I happen to have some very old, like from the 20s and the 30s, magneto pamphlets. Bosch, Splitdorf, Edison. And I looked at these because I was looking for information on magnets. And very often the old manuals will give you more of the why and how versus the new manuals, which are just how to change whatever. And I was hoping to find in here, some method from the, the 30s where maybe you could easily test a magnet. I really couldn't, though. There is some good stuff in here, though. This Bosch catalog has a good description and operation. And there's a very good, 2-paragraph thing. 2-paragraph thing about how magnetos work. And for those of you unaware, the principle is simple. There's 2 loops of wire wrapped around a steel core, primary and a secondary. The primary is thick wire. The secondary is many turns of thin wire. Anyway, as the magnet is rotating, it generates an electric current that flows through the points on the primary side. When the points open, the current stops flowing. A voltage is induced in the secondary coil that creates a spark. That's the long and the short of it. That's all there is to it. It's a pretty simple principle. The other thing I thought was interesting is this Edison one has a paragraph in here about parts and services. Blah, 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 blah. The market is flooded with imitation magneto parts, usually offered at an attractively low price to snare the unsuspecting. Truer words are never spoken. And I'm going to say this about that. You could buy coils on eBay and Amazon for $80. I've had magnetos with one of those brand new coils installed in them, including my own magnetos. And I'm here to tell you, they don't fucking work. I've taken those magnetos, and the only thing I've done to them is replace that $60 or $80 eBay coil with a $130 Morse magneto coil, and they work. I've talked to the guys at Morse Magneto. They claim that they bought from Fairbanks Morse the rights with all the original drawings and blueprints, and there's special ways to wind these things. And I don't know, maybe he's full of shit, maybe he isn't. But in any rate, I will not install one of those $80 coils ever again. I will always spend the more money and get the Morse Magneto coil. They work better. So even in I don't see a date on this. This is probably from the 20s or the 30s. But anyway, bogus parts, they're floating around out there still. They were floating around out there back then. Try to get good stuff or you're going to have problems forever. Besides these things, very informative but not helpful for what I wanted. Being a former airplane mechanic, I also consulted my Electricity and Electronics for Aerospace Vehicles, which has a nice chapter on magnetos and magnetism. Didn't find the information I was looking for in there. And I have my old Power Plants for Aerospace Vehicles, which has a pretty good section on magnetos and aircraft ignition systems and magnetism. Didn't find what I was looking for in here either. But anyway, I try to put out shit that's at least semi-valid. Maybe not 100% scientifically accurate, but I try to have a little basis in reality. All right, I got 4 magnetos over here. I got a brand new Joe Hunt, unadulterated. I got an old Fairbanks Morse mag, and these two are out of the 59 XLCH engine I got. This one produces spark when I test it in the down and dirty, but yet it will not start the engine. It starts the engine 1 out of 60 kicks or whatever. This magneto is out of the 66 that I've got sitting here. It now has a new magnet and a new coil in it, and this has got a Joe Hunt neodymium. This has got a neodymium magnet in it, brand new, and a brand new Fairbanks Morse coil. Hopefully it'll start an engine now. It wouldn't before, but it hopefully will now. And then over here on the end, I've got a magneto that's going in one of my bikes. This one is set up for the tack drive. It'll be a long time before that bike is ready to run, so I'm going to have no idea whether that one will start an engine or not for quite a long time. And of course, this one and this one are supposed to be in running engines right now. No, this one and this one are going to be going into an engines that hopefully will be running soon. So we're going to do the down and dirty test on these things, then take them out, put them on the lathe, spin them, and see how the running test does. All right, first up, Joe Hunt. And you could do this any number of ways. Plugs and wires. I have a copper wire just bridging the 2 high tension posts on the mag. Frankly, out of a brand new mag, I'd expect better. Anyway, it sparks. Conventional wisdom would tell you it should start an engine. Old Harley Fairbanks Morse, all original stuff, nothing's been changed. And I think my eyeball says that's a better spark than the Joe Hunt throws out. Yet this mag will not start a motor. maybe once out of 50 times. Fairbanks Morse mag, new Joe Hunt neodymium magnet, and a new Morse Magneto coil in it. Yeah, it sparks. Frankly, I think it should spark better, but it's not. Okay, and last but not least, old Fairbanks Morse mag with the V-twin magnet and the old Fairbanks Morse coil in it. This one's the one set up for the tack drive hole. And this one kind of seems to throw the best spark. Anyway, that's that. Let's go out to the dirty shop and we'll throw them on the test fixture and see what they do. All right, out in the dirty shop, regulated air supply is set to 50 psi. Got the lathe running about 249, 250. The speed control on this thing is ridiculously sensitive. Very hard to control it, you know, down to a couple of RPM. So 249, 250, that's as steady as I could get it. This is the lowest speed with which the brand new Joe Hunt will produce spark consistently at 50 psi. Here's the old mag running on there, the one the Joe Hunt is replacing. Same 50 psi, haven't touched the regulator. $150 RPM. And just FYI, I have a half of a cap, well, not even a half, but I run these things, these tests, with the half cap on there so that I could see if anything weird is going on with the points, if anything is shorting out. I could also piggyback a condenser in there if I need to, you know, just to kind of see what's going on. So anyway, that's how I run the test, with this half Magneto cap on there. Mag number 3, same 50 psi. I had to crank this up to the same 250 to get a decent spark out of it. This is the mag that's got the Morse Magneto coil in it and the Joe Hunt
neodymium
magnet in it. Alright, last mag on the lathe. This is a Fairbanks Morse with the V-twin magnet and the old Fairbanks Morse coil in it. Same 50 psi. Same 250 RPM, more or less. And it's sparking like a bitch. So, if you're keeping score, here's the results so far. The new Joe Hunt, we're going to install it in a little bit here and see if it'll start an engine. The original Fairbanks Morse mag looks like it should start an engine, but I'm here to tell you it won't. And then we have an original Fairbanks Morse mag with the Morse Magneto coil and a Joe Hunt magnet. We're going to install that one and see if it starts a motor. And then, of course, we have the original Fairbanks Morse with original coil and V twin magnet. We're not going to know whether that starts an engine for a long time. Okay, another corollary to this little exercise is I've had these capacitors in my stash of magneto parts. These are genuine Fairbanks Morse capacitors, and by most accounts, these are supposed to be the best ones. However, when I piggyback them into any of these magnetos I've had laying around, it kills the spark. They don't work. These things, I got a fluke meter that I can measure capacitance on, and these things are all in the neighborhood of, between 470 and 500 nanofarads. The little round capacitors are in the neighborhood of 230, 240 nanofarads. These guys work. The 230, 240 values seem to be the best as far as producing a spark is concerned. These guys are all new old stock. Now, whether they decayed over the 50 years they've been laying around, I don't know. But these guys, these little ones in that 240 area, seem to work pretty good. So I got a chart I'm putting together. I'm going to put all the results up here pretty quick, and we'll take a look at it. All right, so here's the results of my capacitance testing. I had 5 of them little capacitors laying around and 3 of the bigger Fairbanks Morse type. Why the Fairbanks Morse ones don't work, can't explain. They should. If you got a magneto that doesn't work and you've got the ability to check the capacitance, check it out. It's quick and easy, and it might save you a lot of jacking around. This magneto, the brand new Joe Hunt, is ready to go in the bike. This stem over here, part of the base, was too fat to fit in the hole on the bike. I had to put this on the lathe and shave about 3/1000ths of an inch off of it. A little disappointing to have to do something like that to a brand new, made in America, very expensive magneto. But it fits in there nicely now. So we're going to install this and see whether it'll start the bike. And as you may recall from the testing portion of the video, this thing at pressure of 50 psi in the spark chamber took 250 RPM to produce a good spark. I'm disappointed in that. Some of these crappy old magnetos do better than that, much better than that. But the proof is whether or not it'll start the bike. So we're going to see soon. Okay, before I mount this mag and get it in the bike, I got it, clamped up here very loosely in my vise. I want to show you one other thing. This screw right here is the adjusting screw for the points. This is the points spring. This spring is covered with a piece of heat shrink tubing. It's possible for the screw head to touch this spring, and if there was not heat shrink tubing on it, it would short it out and it would ground out your points, and the magneto will not spark. This particular magneto had kind of a domed head screw in here with the lock washer underneath it. I got rid of the lock washer. I put in a very flat, straight slotted screw, and you got to tighten them down carefully. But anyway, there's now a positive gap between the head of the screw and the spring. And just FYI, I've been putting this piece of heat shrink on these things for as long as I can remember. Just in case. I've had magnetos come in that didn't work. I take the cap off and I look at it, and the spring is touching the screw. And it's possible, depending on how you tighten everything up, that you can make this spring touch that screw and short out your magneto. So just be aware. This can be a problem. Use the flattest, shortest headed screw you could find when locking down your points. I've been dicking with this magneto for quite a while now, and I need to quit dicking with it and put it together, which I'm going to do here momentarily. But a recap. This was a standard Harley Fairbanks Morse magneto with the long drive shaft and the magnet. I'm going to put it in a Sportster where I want to run it off the tack drive. So I had to get rid of that magnet and switch to this style with the hex key on the bottom so that it can mate up with this kind of drive that fits into the tack hole. Anyway, of course it had the original magnet in it right here, and this had the shaft on it. I cut the shaft off, machined a hex on it so that I could use it on another guy's magneto to drive a new magnet that I installed in his bike. So anyway, original Fairbanks Morse. This V-twin magnet I bought to use it here. I'm probably not going to use it anymore. Cost $213. The other kind of magnet commonly available is a Joe Hunt magnet. I had one of these. I did some measurements on it, and I had it installed in another magneto that has since been installed in a motorcycle, so it's not available to take a picture of it. $225. This is a Morse magneto magnet. $350, tax shipping extra. Pricey little bastard. But as you're going to see, this one has some things about it that I think it will make it perform far superior to these other magnets. We're going to install it. I'm going to do some measurements on it, and we're going to test it and see what happens. Alright, so here is my magneto set up in the lathe test setup. It's got an original Fairbanks Morse coil in it with a Morse magneto magnet in it. We're going to look at the spark in just a second. Alright, we got my air pressure turned up to 50. Got the RPMs dialed into about 120. Alright, so the lathe is barely ticking over at 120, 121, 123 RPM, something like that. And the mag is producing a spark just about every revolution. This is by far the best magneto I have ever tested. This is just tremendous performance, at least on my lathe. I've got every expectation this is going to start an engine just fine. Anyway, very happy with this. So the Morse magneto magnet and a Stocko Fairbanks Morse coil in here, and this thing works great. Very happy with it. Alright, I'm here to tell you I'm getting tired of screwing with these magnetos. This magneto is a original Fairbanks Morse. It's the one that was out of the Horton. The owner replaced this magneto with a brand new Joe Hunt. I'm not real impressed with the testing performance of the Joe Hunt. It does start the bike a little harder maybe than I think it should start, but it seems like it probably will be okay. But anyway, this one I'm not screwing with anymore. I'm done with that one completely. These two. This magneto is for a future project that I'm working on one of my bikes. This one is a customer magneto. This bike has an original Fairbanks Morse coil in it and a Morse magneto magnet. And when I tested the magnetic field with my Gauss tester, this Morse magneto magnet is 2 and 3 times as strong as the Joe Hunt or as any of the Fairbanks Morse magnets that I have. This one has got the Joe Hunt magnet in it, and frankly it's supposed to be one of those neodymium magnets. I'm a little disappointed in the performance of this. A little disappointed. I'm not 100% sure that it's going to reliably start the bike for this owner. It has a new coil in it. It works. It's got enough new parts in it. It should be fine, but I just don't know. And the last thing I want to do is, put this out to this guy and then have him, be calling me or emailing me, 2 weeks later, hey, the bike is hard to start, it's a pain in the ass, blah, blah, blah. So I had decided that I was going to pull the Joe Hunt magnet out of this one. It's like $250 or thereabout, and I'm going to replace it with a $350 Morse Magneto magnet because they were so much better. Of course, then I run the risk that I'm going to get stuck with a Joe Hunt magnet that I could not really sell in good faith, even though it is, other than, 15 or 20 minutes of testing, even though it is virtually brand new. I just don't have, warm and fuzzy about this one. This one, with the Morse Magneto magnet, this thing sparks like a flamethrower. This is by far the best magneto I've ever tested. It produces reliable spark in my spark chamber, 50 psi, down to 120 RPM. That's exceptionally, like I say, this is the best mag I ever tested. And when I used my new gap tester, it'll throw a spark at 200 RPM, 300 thousandths, 3/10 of an inch. And this guy over here barely throws a spark 0.027 inches at 200 RPM. It should be better. To Joe Hunt's credit, and I was worried they weren't going to take it back. I just called them and they said no problem, send it back. And I told the guy, I says, I test them before I install them because, taking a carb off and on is really a pain in the butt. And I says, I hate to tell you this, but your competition, Morse Magneto, their magnets are outstanding. And I told the guy, this throws sparks like a flamethrower. So I'm taking this apart again. And I probably have had this apart, I don't know how many times, many, many times. But it's coming apart again. And it's going to get a Morse Magneto magnet in it because I'm 100% confident that the Morse Magneto magnet and the Joe Hunt coil, or probably any other coil, including an original Morse Magneto coil, this thing I believe is going to work great. So coming apart again, Joe Hunt magnet coming out, Morse Magneto going in. And then this whole video I made on these magnetos, none of this is unfolded the way I thought it was going to unfold. And maybe I'll talk about that when I wrap this up, if I ever get around to wrapping it up. Anyway, this magneto is out of that bike. It really tested fairly well on my test setups. It sparked, yet it would not start the motorcycle. Put a new coil in it. It helped. I think I got it running once or twice with this coil in it, once out of every 40 or 50 kicks. Not desirable. I tried a new Joe Hunt neodymium magnet in it. Better. Still not what I expected it to be. And, out and apart the mag came, and of course the carburetor's in the way. You got to take it off first. Big pain in my balls. Today I received a Morse Magneto magnet. God willing, this is going to test out much better than the Joe Hunt. We're going to put it in this magneto with this new coil, and that bike is going to start like a whiz. We'll see. And that's all there is to it. Confused? Well, if you're not, I am. Here's the summary. There were 4 magnetos I was working on here at one time. The original mag out of the Hareton, Fairbanks Morse, had some cracks and other issues that made spending a lot of money on it stupid. So that one has been scrapped, so to speak. It had decent numbers, and it seemed like it should have started a bike, but it didn't. It was replaced with a Joe Hunt that starts the bike, although not as easily as I think it should. Then I had the 66 XLCH, original Fairbanks Morse mag, new Morse Magneto magnet, and a new coil. Starts easy, runs great. Then I got another mag for 74 XLCH I'm building. It has a Morse Magneto magnet and the original coil in it, and it tests great on my test setup. Okay, one of the corollaries to all this jacking around is I want to be able to identify a bad magnet, a bad rotor, before I put it all back together again, set the point, set the timing, put the carburetor back on, kick it 50 times, find out it won't start, and then say, well, I guess it must be a bad magnet because everything else is good. So I bought here this Gauss meter on Amazon. It was 97 bucks, 90 bucks, something like that. Chinese. You could spend a lot more money on one of these, but I'm just kind of feeling this all out to see whether it's going to work or not, or whether it has a chance of working. Anyway, these rotors, if you look at them, the magnetic pole is wider on one side than it is on the other side. And for the sake of comparison on all of these rotors that I've got laying around here, I just arbitrarily named the narrow one north and the wide one south, just for consistency's sake. Now, the probe in this thing, apparently this is a Hall effect sensor, and when you put it on a magnet, it will read in milliteslas how much magnetism it has. So I've been checking these things, and this is the one I just removed from the Magneto that had a new coil in it, but still wouldn't start the bike. So we'll start with north, and I just put it on the magnet, and I get a reading of 61. So that is the North Pole top side. Whoops. 61. Now we're going to put it in the middle. And I marked this because I want this always pointing up. And the difference it makes is this. This is north. If you turn this over, now it says south. And like I say, it really doesn't matter which is which for my purposes here today. It just matters that I do it all the same. So I put my black stripe facing up, north in the middle of the pole. I get a reading of 46. And we're going to look at some of these other numbers I have just to see what they mean in a little bit here. And then we'll go to the bottom, and I get a reading of 66. Now we'll flip the magnet over and do the one that I arbitrarily labeled south. So the top of the south one is 56. And I'm doing all three of these places because I measured them all over, and there's different readings depending on where you put the probe. In the middle of the south, it's 42. And the bottom of the south, we'll call it 65. All right, I'm going to try to give you an idea of the procedure I'm using here. And this is trickier than you might imagine. The stock Fairbanks Morse magnet, it's easy to identify where the poles are. You have aluminum and you have the steel magnet, okay? Easy to identify where the poles are. The Morse Magneto magnet has a mark engraved, one mark engraved on the top. I don't know what that mark is supposed to indicate. The cam is staked to the shaft, and the magnet has got one spot weld on the bottom holding it to the shaft, so I can't change any of that. So what I did was I took the factory mark and I divided it into 4, and then I divided it into 8. So approximately every 45 degrees, I've got a hash mark. And I'm recording the readings all the way around. And this thing is tremendously sensitive, this Gauss meter. And moving the probe ever so slightly can move the display quite a bit. So I'm taking 3 measurements at the same spot to kind of validate each other, and hopefully they be within 5 or 10% of each other. But anyway, that's the procedure, and I'm going to try to show you how it's going. Right now I'm on the 180 degree hash mark. The meter is set to milliteslas. If you reverse the probe, and this fucking meter doesn't have any kind of a base on it. Trying to get it to sit in a spot where y'all could see it and where I could see it is kind of a pain in the balls. But we'll give it a try. So anyway, the probe, if you reverse it, reverses the north and the south. And it's indicated over here, north and south. The number stays the same, but the north and the south flips. So I've been using the same side. And like I say, I don't think it matters. And I just noticed now my hand is exactly in the way of the meter. Let's see if I could do this from this side. Okay. And you can see how the meter's jumping around. So I just kind of wait for it to settle. We'll call it 139. And I'll do it again. 154. And I'll do it again. 148. So yeah, we're kind of all in the same ballpark. And then I'll switch it over to Gauss, which really just moves the decimal point over, and check it again. 1577. $16.13. $14.40. And I'll rotate the magnet here another 45 degrees. So now I'm on 225. And I'll do the same drill. Milliteslas, 96. $96. $96. Very unusual to get ones that are that consistent. And then we'll switch over to Gauss, and I expect it to read 960 or thereabouts. 968. $970. $962. And we'll go to 270. This tick mark, and this is probably plus or minus 10 degrees. We'll go back to milliteslas. 156. 154. 161. And we'll go to Gauss. 1550, 1570, 1570. And then the last tick mark is at 305. 6. Okay, I could go on and on and on about measuring the field strength of these magnets. At the end of the day, I happen to have 10 magneto magnets laying around here. 3 brandy-ass new Morse magneto magnets, and I did these kinds of measurements on all of these magnets. I had dozens, if not hundreds, of readings. I put them all into a chart. I averaged them all out, and I have some results we could take a look at. So let's take a look at the results. Okay, I measured all these magnets at the top surface, the bottom surface, and the middle side surface. On the old Fairbanks Morse magnets and the Joe Hunt magnet and the V-twin magnet, the field strength was strongest at the top and the bottom, and weakest in the middle. I rejected the readings from the top surface and the bottom surface because those surfaces do not pass between the laminations that comprise the poles of the magneto. If you look at this illustration, you could see that the lines of magnetic flux pass from the sides of the rotating magnet through the pole shoes and through the coil, not from the top of the magnet through the pole shoes, through the coil, but through the sides. It would seem to me that the magnetic field is oriented wrong in the old Fairbanks Morse magnets and the Joe Hunt magnets. Therefore, it seems to me that the magnetic field emanating from the sides is what needs to be the strongest and what needs to be most strongly considered as far as magneto output is concerned. The test results seem to back this up. The magnetos with the Morse magneto magnet start easier, produce more spark at lower RPM, and have better performance than any of the other ones. Notice the new V-twin magnet is the second worst of the bunch, and you know how I like to pick on V-twin. Notice the 3 Morse magneto magnets have the best side field strength. 2 of those 3 magnets have been installed in magnetos and running engines, and the performance so far has been excellent. Notice that it is possible for one pole to be good and the other pole to be bad. As previously stated, several measurements were taken at each location and they were averaged, so I believe this to be a valid result. This is the Joe Hunt magnet that was returned to Joe Hunt. Based upon my tests so far, I'm inclined to believe that anything above this red line probably will have a difficult time starting a motorcycle, even if it passes the other tests just fine. I'm also inclined to believe that anything that shows a side field strength of essentially 0 ain't going to start a motorcycle either. Just in case you're wondering, and believe me, I am not sponsored in any way, the Morse magneto magnets come in 2 flavors. You could get the one piece with shaft as pictured here. You could also get just the magnet without the shaft as pictured here. You may have noticed in the picture of the Morse magneto magnet with the shaft on it that there was no spiral cut in the shaft for the tach drive. Neither Morse, Magneto, or Joe Hunt at the time of this video making had the spiral cut shaft available. However, if you're willing to sacrifice your old magnet, you could cut the shaft off with a hacksaw, and a competent machinist can easily machine a hex on the end to drive your new magnet. On the top is a normal shaft without the spiral. On the bottom is a shaft that I cut off of a regular Magneto magnet and machined the hex onto. It retains the spiral drive gear for the tach, and somewhat surprisingly, the material the shaft is made out of is fairly soft, and it really machines nicely. So a fairly easy mod to do. Alright, I got a piece of equipment I made several videos ago, and I had been testing magnetos by making them jump a spark on a spark plug in a pressurized vessel. I had some magnetos that performed fairly well in that test, yet failed to start a motor. So I wanted to get another test, and I'm not quite sure how I'm going to use this. This is all experimental. But I wanted to devise another test to add to my testing to see if I could help weed out the bag magnetos. So what I've got here is some brass screws that I'm using as electrodes, and you hook a spark plug wire to here and here, and then by turning this knob you could increase or decrease the gap and make the spark jump a progressively wider gap. I've done some fooling around with this thing, and if you crank a magneto up to several hundred or 1,000 RPM, it will jump a gap this far. It will jump between here and here, and I had to cover the brass screws with a couple of layers of heat shrink and epoxy to insulate them from each other, because I don't want them jumping a gap out here. I want them jumping the gap in here. But you know, eventually you get this gap wide enough, and the spark could jump anywhere. I suppose you could. Well, it'll give you a hell of a shock. I don't know that it's dangerous, but it'll give you a hell of a shock. But anyway, this is a new thing. I'm not quite sure how I'm going to use it exactly in terms of testing magnetos. It's just another test that I could do to see how a magneto performs. And as I test more magnetos and I get a better idea of what performance can be expected, I'll have a better idea as to what this tester actually indicates. But we're going to do a couple of mags. Test a couple of mags with this thing just to see what happens. So here we go with a couple of tests. Alright, I got the Rip'ems at 205. I was aiming for 200, but that speed control on this thing is just ridiculously sensitive, and the slightest moving of the knob might move this thing many RPM. So I'm going to settle for 205. And I've got the new tester hooked up. Okay, this is adjustable, and I want to increase the gap until it quits sparking reliably. So we're going to hold the RPM constant, and we're going to increase the gap and see what happens. There's a 1/4 inch of brass nipple sticking out of either side of these phenolic blocks, so that if I measure this and subtract a 1/2 inch, that's how big the gap is. And this is the beat up old mag with the neodymium magnet in it. They are beginning to become intermittent. And I'm doing this because my other method of testing, some magnetos tested good, yet they wouldn't start an engine. So I'm trying to develop an alternate means here. Well, there we go. I think we reached the limit right there. Okay, so that's 800 thousandths minus 500, so that's a 300 thousandths gap it's jumping before it quit. Alright, I got this mag hooked up to the Planck spark gap tester. We're going to try to dial in 200 RPM again and see what it does. Alright, I got 206, 207 dialed in on the RPMs. And, geez, these things are almost touching and it's not even drawing a spark. Alright, we got some spark. And no spark. Well, that performance sucks. So we got 524 minus 500. So this is only jumping a 0.025 gap. Not very impressive compared to the mag with the Morse Magneto magnet in it. So that concludes the testing with this thing. Like I say, what practical purpose it's going to serve, I don't know just quite yet. I'm going to need to play with it a lot more on future magnetos and kind of get an idea of, what works and what doesn't work as far as whether a mag will start an engine and whether or not this is indicative of its ability to start an engine or not. Just another tool in the box. So let's talk a little bit about ignition coils. I would be remiss if in a video about magnetos I didn't talk about coils. This little diagram is copied right out of the Harley manual, and this is in fact how your magneto is wired up, except for the fact that you probably don't have safety gaps. The safety gap is an auxiliary gap for the spark to jump. Say in case your spark plug wire fell out. The safety gap would prevent the spark from jumping to something else. Say like your right kneecap, which would be next to the magneto while you were driving. The primary is, generally speaking, relatively fewer windings of relatively fatter wire. The secondary is many, many windings of relatively finer wire. The secondary produces high voltage. The primary does not. I got 5 coils laying here. 1 new Joe Hunt, 3 old Fairbanks Morse, and this one is unmarked. I don't know whose coil it is or where it came from. They're easy to check with a fluke meter or a volt ohm meter, whatever you got. When you're testing the primary winding, you're going from the pigtail, which is this lead right here, to that little tab or the core of the magnet. So that would be here. And when you're testing the primary, you should probably be between 0.5 and 1.5 ohms. The primary has got continuity to ground anyway, so you're not going to be able to tell if there's a short in the middle of this coil somewhere or not. Just FYI, the pigtail sticking out of the coil, the other end of this pigtail is this metal tab right here. So they all pretty much have it, although they don't have to have it. But anyway, this end of this wire ends with this metal tab. And you want there to be continuity between these two places. Generally speaking, about a half an ohm to an ohm is what you're going to find. So New Joe Hunt 0.7, and this is the primary winding. Okay, use coil unknown origin 0.7. Old Fairbanks Morse 0.8. Old Fairbanks Morse. Well, that one's a little high. Oh, no, 0.3. Didn't have a good connection. And physically, this coil is in the worst shape. There's little cracks coming off the corners of the core. The towers are all busted up. The lead going in is cracked in insulation. Bare wire is exposed here through the insulation. It's been zipped together over there, twisted together over there. But this one is demonstrably bad. At best, you've got a very intermittent connection between the primary lead. Let's make sure we're getting a good contact on there. Between the primary lead and the core of the magneto. Well, there now it says it's okay. Maybe it's okay, maybe it isn't, who knows. But anyway, you're looking for about a half an ohm. Say a half an ohm to an ohm. When you put your volt ohm meter between the spring terminals on the coil, you're testing this winding here, and you're testing this circuit here. So you want to have continuity, and the continuity should read probably somewhere between 10 and 15,000 ohms, and that would be good. And then you go to the secondary. The secondary is your many windings of fine wire. The New Joe Hunt 15K. And for those of you unelectrically endowed, that's 15,000 ohms. Actually, 15,470 or 460. Here's the unknown origin coil. 13,000 ohms, 13K. Old Fairbanks Morse, 9,600K. Interesting. Another old Fairbanks Morse. Oh, here we go. This one says it's open. I'm making sure I got a good contact on here. Yeah, this one, the secondary is open. This one is no good. Let's go to this survivor over here and see what it says. This one might be 10K. So anyway, that's the secondary. One of the other tests you want to do is between the secondary and the primary to make sure it's open circuit. So if you go from here to here, it should be open circuit. There should be no continuity between the secondary and the primary. If there is, it's shorted out inside here and the coil is no good. And then the last thing you want to check is whether the secondary is short. Well, there's two other things you want to check. Whether the secondary is shorted to the primary, So you go to your pigtail and one lead of the secondary side, the high tension side. It's open and it's supposed to be. We'll do the same thing on this one. Secondary to the primary is open. We'll go to this one. Secondary to the primary is open like it's supposed to be. And let's see, we'll go this one here. Secondary to the primary is open like it's supposed to be. And then this last one over here. Primary to the secondary is open like it's supposed to be. When you test it to ground, you're going from here to a ground or from here to a ground, and that should be an open circuit. And then the last thing you want to check, or the first thing, it doesn't really matter what order you do it in, is you want to make sure the secondary is not shorted to ground. So we'll go to ground, nothing. Go to the ground, nothing. And secondary to ground, nothing. Secondary to ground, open circuit, nothing. And the last one, secondary to ground, nothing. So these all might work. And part of the trouble with these is they could check good right now, and indeed these all check good. One of them had a little bit low, I think it was this one, a little bit low on the secondary side resistance. But they all might work. The trouble gets to be you put them in magneto and they get hot. And you know, you go to the secondary side, when the engine is running, you're producing tens of thousands of volts, 10,000, 15,000, 20,000 volts on the secondary side. So what checks good, powered by a couple of, you know, AA cells in this voltmeter, it might not check good when subjected to 20,000 volts and high temperatures. Anyway, that's the coils. Not a lot to say there. Now, Morse Magneto claims that they wind theirs differently than everybody else's. I don't know. I haven't cut one open, and at $150 a crack, I'm not going to. But anyway, Morse Magneto claims they wind theirs differently. You know, like I said, I can't prove it. I've never cut one open. I do know that I've worked on magnetos where the only thing I've done is change a new eBay $80 coil for a new Morse Magneto $160 coil, and the magneto worked fine. So maybe there is something to what they say. I don't know. But anyway, that's coils. Not really a lot to say about these. Not doing any research on these. I'm just accepting the fact that the Morse Magneto and even the Joe Hunt ones are going to be by far better than any of those $60, $80 ones you see on Amazon or eBay. Well, I got to end this video sometime. It's gone on longer than I thought it was going to. There is more that I could say. There is more detail that I can go into, and I might later on, but not now. So we're going to end this with a little demonstration. I got here my half a magneto cap. I've added 2 pieces of vinyl tubing to the towers where the springs go, and the 2 pieces of vinyl tubing are intended to reach down inside these towers on the coil. And I'm doing that to try to prevent the spark from jumping from one spring to the other spring, because I know that it will, because I've fooled around with this before and I can make it happen. But I don't want it to happen today. I want the spark to jump somewhere else. I'm going to be revving this mag up, and I think I could make the spark jump a very wide gap up to the point where I think I could probably damage the insulation inside the coil, because the voltage will be getting very high. How high, I don't know, but very high, let's just say. So I'm going to cut the demonstration off when I think I'm in danger of damaging the internals of the coil. So I've got this magneto, which is the one I'm going to use in my next project, which I believe to be a very good magneto, hooked up to this spark plug gap jumping thing. And this is just for fun. This isn't to prove anything, but we're just going to see how big of a gap this magneto will make a spark jump. We'll dial in about, I don't know, 600 RPM on the lathe. That's 596. If you got a mag on a bike and it's missing at high speed, probably isn't the magneto's fault. I think you can hear that. For the record, I'm at 600 RPM. You know, your bike might be going down a road at 3,000 RPM. I know that I can make this gap bigger. I'm scared that I might damage my coil internally, so that's all the farther I'm going to go with it. This particular magneto has the Morse magneto magnet in it and a regular old Fairbanks Morse coil in it. Yeah, that's some serious spark right there. I ain't going to touch it. Want me to touch it? I ain't going to touch it. Anyway, with that, I am out of here. I hope you enjoyed this series on magnetos. Maybe there'll be a little bit more later on. I got a couple more ideas I want to work on. But for now, that's it. Y'all take it easy. We'll see you next time. Thanks for watching. Just a quick reminder, you can help support and grow this channel, first of all and most importantly, by hitting that subscribe button. So if you haven't subscribed already, go ahead and hit the subscribe button. If you'd like to do a little more, join me on Patreon. Links down below. So go ahead and join me on Patreon if you feel so inclined. And finally, coffee cups, stickers, and gas tank covers are available. This is a new design coffee cup. I like the old ones, but I like these new ones even better. Links will be provided in the description down below. Get yourself some. And thank you all ever so much for watching these videos. I really appreciate it. Bye.